power series centered at A is kind of, you can think of it as a generalization of a polynomial. So a polynomial would be something like what I've written, except in the upper limit, instead of having an infinity, we would have some finite number. And so, for example, the finite sums here, the partial sums here, are polynomials. So power series is in some sense a generalization of polynomials. It's a limit of polynomials in that sense. Okay, a kind of imprecise but maybe useful way of thinking about it is that it is an infinite degree polynomial. Now, by definition, polynomials have finite degrees, so that's kind of a strange thing to say, but it's at least one way to think about it. And in fact, power series and polynomials have a lot of similar properties. If you want to know more about stuff like that, that's covered a lot, actually, in a class called Complex Analysis, which is Math 407. So if you want to learn about power series more in depth than what we're talking about now, that's my plug for Math 407. Okay, so now I want to answer the two questions. What is the radius and interval of convergence? So this is a series. So whenever we have a series, we have to talk about convergence. But not only is it a series, it's a series with a parameter x. So x can vary. It's a variable. So we would expect that perhaps sometimes this might converge for some values of x, and it might converge for other values of x. And this is where the ideas of radius and interval of convergence are going to come from. But really, to define these two things, we first have to state a theorem, and this theorem is the following. It says that one of the following three things happens. Either it converges, either it's absolutely convergent, not just convergent, but absolutely convergent for all x. Two, it converges only for x is equal to a. Well, if x is equal to a, then we're just basically adding up a bunch of zeros, except for the first term, everything else is going to be equal to 0. And 3, it converges for, let me write it this way. There is an r. There is an r such that it converges when the absolute value of x minus a is less than r, and it converges absolutely even. It diverges when the absolute value of x minus a is greater than r, and when the absolute value of x minus a is equal to r, we don't know. We'll have to test it. The r in this theorem is called the radius of convergence. And the interval of convergence, well, the left endpoint of the interval is going to be a minus r. The right endpoint is going to be a plus r. And then, in general, some series might converge at the left endpoint, but not the right endpoint. Some series might converge at both endpoints, diverge at both endpoints, and so on and so forth. And whether you put a closed bracket here or an open bracket here, it just depends on the exact problem. So that's a little difficult to say. So whether or not the interval includes the endpoints is something that is determined on a problem by problem basis, and as we look at examples, we will see more and more about how you make that determination.